Today we are creating close volume. This will be a quick video. Please comment if you need anything. So without further ado, we will start. So this type of surface is given for the close volume, and if you are giving us test, this will be given in another geometrical set. You have to create all this geometrical set. You can take a screenshot or you can note it anywhere. So we will start the close volume. So okay, so we will disassemble this surface. This is the single surface and there are some missing patches here, so we will create that and we will make a close volume. So we will disassemble this, define the A work, disassemble this surface. Okay, hide the styling surface. We will create a main tooling direction. So for that we will insert geometrical set mtd. Okay, so for creating we will hide the master section. We will take these two lines to create main tooling direction. This is one of the method to create main tooling direction. So there are other methods are there also to create main tooling direction. So that I will upload another video for creating our methods to create main tooling directions. So we will firstly create it for here. Now we will create a point, isolate that point. We will take these two as a reference, these two lines, select the bisecting one. If your surface has any features like this, then you can use this method to simply create main tooling direction. So this one is the right solution, so no need to go to the next solution. So we will click OK, change the properties of this line. Firstly isolate this one, delete the point and rename it mtd. Okay, we will change the properties. Okay, so our tooling direction is now done. We can check that by hiding this surface. We can check the draft analysis for the styling surface. So put it in the material mode. We can so as you can see, the surface is cleared in main tooling direction on all the sides. So this tooling direction is okay. So we will click OK, hide the styling surface, A surface. We will now create B surfaces, B surface offsets. So while doing that, for B surface give different color, for C surface also different color. So why we give different colors to the different surfaces? Because to avoid the confusion between them. So while offsetting this, you can easily see that it will be in different colors, so no confusion there that this is the B surface and this one is the A surface. So always remember that to give different colors to the different geometrical sets. So I will delete that. We will check the part thickness required in the master section. So we will measure that. So this one is the 2.5 part thickness. So we will create all the offsets for the 2.5. So I will quickly offset all the surface in the 2.5. Okay, so as you can see, this fillet is a smaller one. So if we are going to offset it inward, it will not offset, it will give an error. So no need to offset this type of fillets, these smaller fillets. We will directly create a sharp edge with the offsetted surface from this. Okay, so this surface is now created. If there was any gap between these two surfaces, we would have to extrapolate this surface and this surface, and then we will split that both of the surface with each other. So for now there is no need to here, because the offsetted surface are ready to join. So before that we have to create the missing patches between the A surface. So we will again define to the A work. So that was remaining, sorry. So we will create it from multi-section. Select the edges as a section and give the tangent surfaces beside them. Always remember to give tangent surfaces, tangent continuity. Okay, and for this one, okay. So A surface is done. So we will go back to the offsets or B offset. So we will create offsets. Okay. So offset surfaces are now done. We can join the B surface, but before that we have to extrapolate these surfaces, these edge surfaces, because it is easy to split when we extrapolate the surfaces at the end with the C surface. So always remember to extrapolate the surfaces at the end. Here extrapolating, always use curvature continuity, as it will not create another surface for that. So I will show you here. I will use tangent one, so you can see under the lines this surface is now newly generated. So to avoid this we will use curvature continuity. So same surface and it is extrapolated also. Okay, now the offset is remaining. So we will again go to the offset and you offset all these surfaces. So so for this fillet, these are also small fillets, but we are offsetting it outward, so that is why it will be offsetted easily. Okay, so now B surface is done. We can join the B surface. So we will join B surface. Select one surface, then go to right click and distance propagation. We can join it in 0.01 merging distance. Also join A surface. So we select one surface, change it to 0.01 distance propagation, preview. Okay, yes. So C surface, we will extract the boundary. We will take the boundary of the A surface, and from that we will create C surface. So we will check the master section for the sea surface. So with the main tool and direction, we will check the angle of the sea surface. We will directly measure this one and this line. So as you can see, this is the 90 degree. Check for the other side too. So it is also 90 degree. So we can directly sweep it for the 90 degree. So we will use sweep with draft direction. Select the guide curve and the draft direction. So it is already 90. We will take it inward. So it is 5 mm. We will preview and then OK. So your C surface is now done. We will go to the ABC split, define it. We will split the B surface with C and C with B. Okay. So now we will do the final join. So final join, select all the three surfaces or directly this distance propagation 8. Okay. We can change the merging distance to 0.01. Okay. So to check if it is closed or not, we can directly select this join and select the boundary option. So it gives an error. The selected body is closed, it has no boundary. So this can be a method to check if you have closed volume or closed body. So if it is not, then it will give you error. It will not give you error, it will directly show the boundary on the via uh, the area which it is not closed. So you can use this method. So we will now create a body. Okay, so we will give closed volume. We will go to the part modeling. We will select the close volume command. Okay, select the join. So your close volume is also done. We will create a parting line for this. Rename parting line. So go to the surfacing again, select a extract with the tangent continuity. Okay, hide the close volume body, then take the edge of that surface. This is easiest way to create parting line. Change the parting line properties. Okay, hide the surface. Your parting line is also done. So you can see that this is matching with the your master section. Okay, so and remember, don't keep sharp edges in the part. So we will define this close volume, go to the part modeling, give fillet. You can give minimum fillet 0.5 to the both of the sharp edges. The the parting line will remain sharp, and other surfaces you have to give fillets. Okay, so we will now check in the draft analysis also. So go to the material mode, select the part. Okay, so it is now clearing in the main tooling direction. So thank you for watching video. Please like, share and subscribe.